Chapter 11, Part 2, Net Present Value and Internal Rate of Return. Now, these two methods, we do take into consideration the time value of money, i.e. $1 today is worth more than $1 in the future because of interest. And so we have these two methods, net present value and internal rate of return. So that's what we're going to cover in Part 2. Now, we use the time value of money to compute the present and future value of single lumps, sums, and annuities. So, net present value analysis applies the time value of money to future cash inflows, and we calculate net present value. We're going to be discounting the future net cash flows for investments at the required rate of return. How much do the investors expect to receive if they take their money and put it into the project? So we're going to look at the present value of the future sums we're going to receive and subtract out what they want to initially invest. So net present value usually require a minimum rate of return, and the proposal must exceed it. And you must take into consideration all cash flows, including residual value. And we're going to use a present value table. So again, what we're going to do is we're going to take the present value of the net cash flows, subtract the investment, gives us our net present value. And if the amount is greater than 0, we'd want to invest because we're getting the return at the rate we want. And if it's less, then we don't want to do it. So we want the one with the highest positive net present value. Again, time value money. Invested money earns income over time. Cash received sooner is better than in the future. So here's the factors. If we have a principal amount, if we have a single lump sum or unequal payments, the table we're going to use is the present value of $1. That's where you're going to get the factor. Okay, so even though you have a stream of funds, if they're not the same amounts, you have to go for each one to the present value table. Now, if you have a stream of equal payments, then you're going to use the factor from the PVA, or present value of annuity table. And you'll see those as part of your homework. So then we're going to take the factor times the principal amount. And again, when you get that factor, it's located, you select which table you want to use, the PV of $1 or the PVA of $1. And then you're going to get to a table and you're going to go down the left side based on the number of periods or years. And then you're going to go across the top based on the interest rate. So again, the decision is the net present value positive. And if it is, we're going to invest. So here's an example. We have Mike who's trying to decide whether they want to invest in solar panels. The project would cost $550,000 and would save $80,000 a year. The panels have a 15-year life and no residual value. First, what's the payback? The payback is almost 7 years. That's a long time. A lot can happen in 7 years. If the company has a discount rate of 10%, what is the net present value of the project? So, the total investment is $550,000. We go to the present value of an annuity table. Why? Because this has the same fund that we're going to receive over, 15 periods. So we're going to get that factor. We're going to go to the PVA, present value of an annuity table. And the factor on the left side is going to be 15 years. Interest rate's 10%. And we're going to get this factor. And they're telling us that's the net present value of receiving $80,000 a year if we had a return of 10%. Now our net present value is $58,488, which means that our return is higher than 10% because the net present value, if it had been 0, that means the return was exactly 10%. But since it's greater, that means we have a higher rate of return. I say the only problem with this project is it's going to take 5 years or more to get start getting, further payback. And if we're saying that we have, we don't want more than 5 years, then we wouldn't do the project. But if we did it based on net present value, we would, if we had the capital. Now, net present value for unequal cash flows. When you have unequal cash flows, you've got to use the present value for each year. So here is an example. We have project C and D. They both require an initial investment of $80,000, but they have unequal cash flows. So for project C, we're going to take the $25,000 times the present value factor that we get from the PV of a dollar table, since it's a single sum. Then we're going to take it for 2 periods at 12%, and then for 3 periods at 12%. And again, we get these from our present value of a dollar table. We're going to add those up. We're going to subtract our investment, and we have a net present value $13,688, which is greater, which means our return on investment is greater than 12%. Now, project D. We do the same thing with our factors. And we also had an initial investment, but look at the difference. We have a present value of $24,000. Now, why is it that you have the same sum of you're going to get the same amount of money back for the same investment? Here's the difference. If you look at project D, we get most of the money back in the first couple of years. In project C, we don't get most of the money back until the 3rd year. And the further away the money is receiving the money, the less value it has in today's dollars. So based on this, even though they both have the same initial investment, we would go with D. Okay, we would go with project D. Now, comparing net present value, there's something they call the profitability index. So what this does is tells us how much of every dollar invested we're going to get back. And it's going to be returned to us. So let's take a look at project C and D again. And here's the profitability index for project C. And for project D, obviously it's more. It's $1.31 per dollar invested. So we would definitely want to go with project D. Now let's take a look at another example. We want to buy equipment that has a life of 6 years, and they have a required rate of return, because they're going to automate production. It costs $910,000, and they have a required rate of return. Now compute the net present value of this project, and should they invest? And those would be our cost savings. So initial investment is $910,000, and then we're going to have to go to the present value table for each one of these. Then we're going to add all of those up, and we're going to get $840,584, which means our net present value is less, which means that we're not going to get a 16% return, and if that's what's required, we would not do this. Now, if we're to comparison, net present value, the advantages are it incorporates the time value of money, and it indicates if asset will earn minimum required rate of return. The disadvantage is it's difficult to compare investments of different sizes, and however profitable index can be computed for capital rationing decisions. Now let's take a look at the internal rate of return. Now I want you to know in this textbook they've really simplified that, because they don't actually make you do it. So the rate of return a company can expect to earn by investing in a project. So it tells you what the actual earnings are. So the interest rate that will cause the present value to equal 0. Now this is easy to do if you have an annuity, i.e. stream of the same funds every year. However, it's more complicated, and don't worry, you don't have to do it if you have unequal sums. So, annuity present value factor is investment divided by the annual net cash inflows. So, and then you would go to the present value table and try to find a factor close to that, and it'll give you an idea what the rate of return actually is. So let's take a look at that. So remember, the internal rate of return, we want to see if it exceeds our hurdle rate. If it does, i.e. what do we expect return versus what it actually returns, then we'd want to do the investment. If not, we would not. So again, does internal rate of return exceed required rate of return? If yes, you would invest. So, to compute the present value factor for investment project, you take the initial investment divided by the annual net cash flows. Now remember, that formula only works if you've got an annuity, i.e. the same amount of funds you're going to receive every year. If not, it doesn't work and you have to do it differently, which it shows you in the textbook. So here is our example. We have two investments. Two different A and B, and the investment is $228,000 for each. And we have Project A's cash flows and Project B's cash flows. They're the same, but we get them at different times. So for Project A, we're going to have to use present value factors because the funds are uneven. And in that case, it turns out that the internal rate of return, I can tell you right now, is less than 12% because we have a negative net present value. So we wouldn't do that if we demand that the minimum rate of return is 12%. Now, for Project B, it's different. We have a net present value of $2,573, which tells me that our internal rate of return is higher. So we would go with Project B. So what do we do? What's the internal rate of return? Well, we would take our investment of $228 and divide by 96,000 because in Project B those funds are equal. We get 2.375, and we look at the present value table of $1 for 3 periods, and we go across. We see that the 2.375 falls between 12% and 15%. But unfortunately, they don't do 13 or 14%, so we only know it's within that range, which means it's returning a better return than 12%. So we can't do it for Project A. Let me go back there. We can't do it for Project A again because the funds are unequal. So in this case, again, we would still pick Project B. Now, comparison of the capital budget internal rate of return. Advantages: incorporates time value of money and net cash flows, computes unique rate of return, i.e. computes what they actually return, no additional steps needed for capital rationing decisions. Disadvantage: assumes that all cash inflows are reinvested at a rate equal to the internal rate of return. So let's do a summary of our methods. So again, if we do a payback, the focus is on cash flows. It shows you years before you get your money back, and it's very easy to compute. Same with accounting rate of return. We use income. You get a percentage. Again, it's easy to compute, but both ignore the time value of money. Net present value is more difficult to compute. We're going to focus on cash flows just like we do for the internal rate of return. For net present value, we're going to get dollars. Internal rate of return, we're going to get the actual return percentage. Okay, so I would say you would try to use as many methods as possible when you're looking at capital budgeting. But here's the big thing I have always been told. You can have a fabulous project with fabulous projections, but it really has a lot to do with the management team. Who's going to implement it? The stronger the management team, the better chance of success. And that ends Chapter 11, Part 2.